Yeah, I'm Björn. I'm working at Dassault Systems. I'm a chemist. I work from Germany. And thanks to Technia, I'm here today to speak to you. Okay, the bridge to material science was cybersecurity, material science. Indeed, what I just explained, I experience very often. And to me, it was much surprising that in these material innovating companies like Evonik, BASF, everyone who really creates materials, chemistry, all this security, information security is really a big, big concern. And even more than in life science. Why? Because they work business to business. So they work for Porsche, they work for Audi, they work for whoever, and they get the task to create an innovative material for them, which they use then in their products, in their cars, in whatever they produce. And then they have strict confidentiality rules that not even others in the same lab who are not working on their project are allowed to see it. And this is, of course, a killer. That's a showstopper, absolutely, for the things we want to talk about. Learning from your data, sharing data, putting AI technologies on that data, because we all know we need to feed in a lot to make them learn a lot. But anyway, let's probably first come to a lot of the basics here. Okay, so my talk is called Material Innovation and in Silico Modeling, but before we go to that, I thought half an hour after the lunch, you are all quite dead, so let me start the video here. No sound? Or? That's a video game I played a lot, actually, in the 90s when I was still studying. And of course, the idea is don't go to the dead zone when innovating your materials. So the ones who know, these lemmings, they always walk, and without your guidance, they just all die. And you have to rescue them, so you have to guide them in a good way. And we want to guide, of course, material development into the correct way. And this is hopefully what we do with this new technologies like material innovation could, of course, include in silico modeling and AI support during your formula design already, leading you and guiding you into the good direction and not into the dead end, so to say. Okay, I think who doesn't know what Dassault Systems is doing? Everyone knows, that's cool. So I can be very, very quick. We are a software company. The interesting thing is on the right side, we serve a lot of industries. And now, of course, the common question is, what is common for all these industries? Each and every of these industries, although it's not obvious, they use materials. And their products are based on materials. It's probably not obvious, but yes, it's true. No matter if you're a life science company producing drugs, APIs, formulations, or cars, even cars. Everything is on materials, and it's high performance material to serve you better, actually. So, and so that's, of course, the credo that material innovations will bring us to the next level. And of course, performance, competitiveness require also each and every day material innovation. And of course, these materials and materials processes are catalysts for product innovation. Materials by themselves do nothing, or most of the time do nothing. There's a few exceptions. Water, we can drink water, but only if it's clean. But other materials, you need to assemble them, produce formulations, create products out of them to really help you, right? Okay, and this is actually what's used, and this is again a repetition of all these industries. Each industries use materials, no matter if it's pharma, with drugs, therapeutics, food and beverages, feed the world, home and personal care, medical devices, electronic devices, all kinds of super different materials. Of course, in the automotive area now, very big, all these batteries, not only in automotive, everywhere. Lightweight materials, composites, additive manufacturing, also totally new world. If you think about materials who are assembled or printed by these printers. And yeah, every industry needs materials, innovative materials, and produce better products. And this is our only Dassault Systèmes slide now, because it's probably a little bit unfamiliar. So I'm from the BioVia brand. This is why it's flashing and blinking here. And you have seen very often, I guess, the Dassault history. But if you look at BioVia, we are actually even a little bit older than Dassault Systèmes itself. So it started out with chem information companies like MDL, who really invented in the late 70s the method how to store chemical information on computers in databases. And I can tell you, we developed this industry standard and it's still in use, even after 40 years. It's the same thing. It was developed, yes, but we own that. Used everywhere on the world. And combining with some other companies, you see a lot of combinations and mergers and acquisition till we got BioVia. The interesting thing for you is that these companies were specialists, in storing scientific data, and by that I mean chemical, biological information, doing molecular modeling, so using ab initio principles for doing modeling and simulation based on the molecular structure. And later, some might heard it, Pipeline Pilot brought in a lot of pipelining technologies and machine learning capabilities. 20 years ago, we called it machine learning. Now it's more called AI. But it's more or less the same thing, no matter if it's genetic algorithms or neural networks or simple decision trees, it's machine learning and AI. And this is what we do. And what do we do with this? Well, we create new materials. And of course, the ambition is to not produce materials anymore in this top-down approach, where we assemble stuff to do some work based on what we have. Of course, we want to design new materials. And this is what happens in all these industries actually every day. They design new cool stuff, new materials for fulfilling a very specific purpose, actually. And the new thing obviously is, and I think this is a good example, somebody told me, I don't know if it's true, that these rotors are hard to recycle. So what they actually do, I'm not sure if it's true, they bury them because they don't know how to recycle them. So we see even if we produce cool things, there is new challenges like the sustainability challenge coming up. And this is just a summary slide of some of these challenges. Of course, the materials need to be affordable. Consumers must be able to buy the products out of it. They must have maximum performance. Then, not obvious maybe, but oh yes, obvious. Most of the materials are formulations, what we call it. Compositions of a bunch of materials. And this brings, of course, a lot of questions, a lot of problems, how much of the material, but also the processing is, of course, important. Don't forget about it. Whatever you produce, you can do it at different temperatures, different pressures, different orders, different whatever. So the process parameters. And this, so the optimization problem explodes if you think about it, right? And this is the new thing, but a good thing, of course. We also learned this morning, material development and its life cycle of the material needs to be as sustainable as possible. Easy to clean, produce and dispose, low energy consumption, low ecological footprint, healthy, and ethical, of course, also. Well, this is a CPG slide, but you all know it. We get more and more humans, and if we want to treat itself ethical, we also need to feed all these people, right? Okay, the consumers. So I spoke about industry, but what does the consumers tell us? And they did polls, and luckily, I think a lot of people act ethically, and if they are asked, do you want to buy more sustainable products, 80% say yes. Or in polls where, I'm not sure if they only ask women like it's positioned here, 50% or no, 45% of the women say, yeah, we want to have more natural products in our skincare products, which is super cool. It does not sound too much, but I think the other 50% would say, I don't care if it works. So they would also buy it. So it's not too bad, actually. And then, of course, health and nutrition. We all get older, we all get maybe a little bit more weight, so everyone thinks about that. We want to feed ourselves more healthy. And it would be easy if all consumers would be the same. And now let's play this video because it's actually a marketing video, but it's actually very nice, summing up how consumers are different.
For a long time, launching a quality product at a fair price was enough to win in the marketplace. Huge brands have been built by delivering a strong consumer perceived value. But consumers today are different. It's not just that tastes and preferences have evolved. Now there's a massive fragmentation of beliefs and ideals.
I care about brands that care about the environment.
I only buy food that's gluten-free.
I love beauty products, and I really respect the opinions of this one blogger I read.
The product's packaging has to be recyclable.
When I shop,
I want to be entertained.
Not bored.
And compounding all of this, new consumers are a moving target. Their preferences can change at the speed of social media. As consumers continue to evolve, the traditional innovation model is no longer sufficient. Product life cycles are getting shorter because of changing consumer dynamics, and companies that cannot accelerate their development and scale up cycles will be left out watching competitors who can deliver. The traditional innovation model is no longer sufficient for today's consumers, but an integrated business platform can deliver powerful brand experiences that will capture minds and hearts.
Yeah, I like very much this sentence. I want to buy what this one blogger tells me, but you see how complex it will be, for example, for the CPG companies, how to innovate that strong. And I hear it every day from my daughter, for example. She tells me, Dad, you shouldn't buy these shampoo bottles anymore with all that plastic. You should buy these more soap, this solid shampoo. And of course, imagine what a big step it is for a beauty company to go to a new product which has a different delivery form, all the productions. It's easy to fill in a bottle with a different flavor, but it's totally something different if you need to adapt to a new market trend that quickly. Well, and
for a long time, launching
we need to that we skip. So now we are come to the topic of the talk. Finally, actually, our belief, of course, at Dassault Systems is to keep innovation by extending the virtual worlds and improve the real worlds with simulation and modeling and AI technologies. And in the world of material development, this is the typical process, I would say, or the traditional process you see here on the right side, actually more, that you go to the lab, you create a series of formulations, we call, or recipes. You do variations of it. If you are super clever, you use design of experiment software to find the best space out of it, and where should I start to find all the correct corners of my development space. And then you test these, and then you analyze the results, and then you have some new insights, and then you know in which direction to develop. And of course, the plan, the idea is to initiate this virtually in silico, as we call it, by computer technologies to generate a new set of formulas by using probably AI-assisted data or models which you train from your data in your systems. Or you do the activity, the assays, as we call it. You test them with ab initio first principles, molecular modeling. Then you score it, you refine and do this virtually. And then, of course, come somehow to the real world back, and hopefully you have a much better starting position as you had without this AI assistance. And this you can, of course, apply to the whole material life cycle. Now we are a little bit back with PLM. You might have seen this. So if you produce something, it's the material by itself or the unit, the engineering part, whatever, but it has all the packaging, the consumer units. You can do modeling everywhere. You can packaging assembly. We at BioVia here, we are concerned about the real product, I would say, or the material, which is then the recipe, the formula, which means all the ingredients, the process parameters, as I said, and then we try to help here with simulation, modeling, and machine learning. That's already at least the ambition. We are not there yet, but we are working on that. Okay, what can we deliver? First of all, we deliver laboratory support, laboratory execution, And we do that all on the platform, I must say. So I was actually very happy that Hans, or how do you pronounce your name in Swedish, mentioned that this is one of your challenges, right? In the PLM, you said, actually, yeah, we need to also store chemical data. We need to store biological data. That is something which probably was missing. And now you try to understand what we do, what is our ambition here. We teach this PLM, these languages of biology and chemistry and science, actually. We enable modeling. We try to unlock the innovation with AI, machine learning. So that's where we internally do some work. And of course, part of it is this formula and recipe development. And if you look at these formulation design workflows, so from the early beginning, from the formula briefing up to the recipe design, what we exactly want to do is actually then move all these testing, activity testing, sustainability checks, regulatory checks. We want to bring that up and do in silico modeling, AI, machine learning to, at an early stage, even when designing the formulas digitally on your 3D experience platform, that you already can predict the outcome and if it makes sense to go into this physical loop of make and test, which is very time consuming and of course very dirty. You produce waste. That's it. Okay, but that's not all, because unfortunately there's a kind of a hidden component when we want to do it. Because you saw, I showed you our history. We know how to do modeling, we know how to do machine learning since the 70s or 80s. So, but what you also really need to do is you need to democratize these technologies. You need to make them available for the scientists who work in a lab, who probably are not experts of these simulation tools. And this is, of course, a big challenge. And this is what actually all these digitalization and experiences we hear is about. That even a researcher can have a good experience, have access to the model, and can use it, and can know that it's robust, actually. And this is really something which is not easy, but nothing else which ChatGPT does, for example. So it makes it available for the user to use it. And this is what we need to do as well. Well, what is our plan, at least in this very specific formulation design area? So formulators have normally a very similar way how they work. They like these kind of Excel views, creating formulas, having materials, having process instruction, having the amount of the materials, a little bit like Excel. They even like to compare it, have it side by side with Excel. So that's very common. But what's the difficult thing is each industry has very specific needs, what calculations and predictions and things which they want to comply to. Of course, the food industry has a little bit of different compliance rules than probably some heavy metal industries, that's for sure. And this is why we need to bring that in kind of flexible. And this is actually what this right side shows. So here, different for different industries and different research areas. So what we are developing is the virtual companion, which is a flexible, configurable execution framework to extend the formulation design capabilities. So that meaning reading the recipes and information which is needed for this recipe and simulate, calculate, predict additional properties from that data actually. And that needs to be flexible because everyone wants to have different things. And it gets more complex if you are on a 3D experience cloud system where you want to sell software as a service, so without any customization. So it needs to be somehow configurable. So the technology we have is this pipeline pilot technology where you can assemble these, we call it low-code programming, where you can assemble these pipelines, you read recipes, then from your recipe management tool, might remove dirty things, read additional data, do all the magic. Here we have these components for this AI machine learning capabilities, which you can then bring in, and then you store or display the results to the researcher. A long way to go because we are in the moment porting this from our traditional on-prem systems into the 3D experience platform. So still a lot of work to do. So not asking me, please, can I have it tomorrow? No. please ask me, can I have it next year? I say, yeah, maybe. Here is some prototypes how this would look like, and I just assembled some from different industries, I think. So let me see if that works here. Some videos. So here it says a new formulation should be actually created, and so you hear the 3D Experience platform. You see here the formulation designer that is available. You can buy that today for your formulation scientists. Then you add this virtual compliance tools, and then in this case, because it's a food thing, you can actually predict all kind of Nutri-scores. You can here predict the sensory of the yogurt. In this case, it's a yogurt. Then you can check the compliance actually here. Of course, this is now, you select the usage, you select countries, and this is where all these legislation and compliance rule comes in. We are partnering with a company called Food Chain to bring that in. And then, of course, we see, unfortunately, here in Indonesia, this probiotic yogurt cultures can only have in a lower concentration. So the formulator can immediately go and then lower this concentration here. Does it much lower, because we want to have this yogurt also sold in Indonesia. And then, of course, he sees while he's doing so that he's now compliant in Germany and in Indonesia. And the Nutri-score, I admit, is a little bit bad with E, so maybe they should work on that too. And on the sensory panel, yeah, here is what we can use with artificial and machine learning, because this is a now not existing formula. We need to somehow predict this. But of course, if you in a big company have this sensory data, you can train the models, you can feed it in, and then you can predict these things. That's actually the idea. Do I still have some time?
We should leave the room open to open the room to some questions, unless you.
Okay.
Is this the last slide, or?
No. This is one where I really go into another food thing, but we can skip it. So it's about process parameters, so about processing. But let's do this in silico modeling, because that's also nice, because this is really using ab initio calculations for really calculating the skin permeability of a new sunscreen. So this is again a new formula. Add new ingredients to your formula, and it's about the new sunscreen trend which you put on the skin. But of course, then you can easily then create this formula. All the ingredients are analyzed, and then you can put it into your virtual model of the skin permeation. And then behind the scenes, really a scientific method is used. So it's called CosmoRS, predicting how much these chemicals like to go into solvents. And well, actually, you even can model the skin as a highly structured solvent, if you wish. And then this study, of course, then shows you that one of these ingredients you plan to do has a too high permeation of this into the skin. So it would not make sense to use this, or it would be even dangerous. So you shouldn't do it like this. And then, of course, easy, the formulator sees the results and absolutely can then change the ingredient, run the screening again, and find a better thing then. And with that, I think that were only two little examples now where we see that we can bring this early on into the formulation and design process. And this is, of course, results to getting the formula right first time, hopefully, leading to less number of created samples and batches, less number or no animal tests anymore, hopefully, less waste, less pollution, less time spent on development process, less money spent on development process in that case, and hopefully also better products. And all in all, of course, then this leads to a more sustainable development and a more sustainable, better product. The things we need to definitely work on, it's a huge task, to be honest, and we are really at the beginning, I would still say. But the real problem with material innovation is also each formulation consists of many ingredients, and these raw materials or ingredients, however you name them, they have, of course, a life cycle as well. And let's say putting into account all of these sustainability measurements from early production or lithium batteries? Is the mining in the third countries, is that really something sustainable? That is a huge task, that for a given set of materials, even if you know them well, it's still a hard task to judge on their sustainability. And with that, I apologize that I speak fast, that I wanted to squeeze as much as possible in, and I'm happy to take some questions if we have the time.